Alright, so we're going to real quickly talk about the first three sections of Chapter 9, which deal with our first packet. And this is all about translations, transformations, where we're basically, transformations where we take some figure and we do something to it, where we change either the position, the shape, or the size. And we have some basic ones shown below that we're going to look at in these three sections. But we're just changing, the key thing, most of the times we'll just change the position. We'll not as often change the shape or the size, but we have a flip. You can think of like a mirror image, so there's some line that it flips over. We have a slide, so we move a point from one point to another point, and then we have a rotation or a turn, so we take a point or a round point, we turn the whole thing so that it's in a different orientation. And you'll notice with all of these, we have an original image, so original figure, which we call the pre-image, and then we have a resulting figure that is called the image, and we want to make sure that we keep track of which is which. So I have an original, which is called the pre-image, and then I have some transformation. In this case, I'm going to flip it, and then I have the resulting image, which is called the image. Alright, we also have some language down here at the bottom that we really want to key into called an isometry. So an isometry is some transformation, so in this case flip, slide, or rotation, where the pre-image and the image are congruent. So we haven't changed the size or the shape. We're left with the same figure, just in a different spot or orientation. So that would be an isometry. All of these are isometries, as they don't actually change what the figure looks like. It's a congruent figure. Right. We do have some notation around this that we want to make sure that we're aware of. And so for this first paragraph, the key idea is that we have a transformation. Our notation is with this arrow, and then we use this basically apostrophe to identify image points. So if we look down here, K is the image, and that means that it came after K. And so the way we show that is K as some transformation onto K prime. We call that little thing K prime, and that means that these two match up with our transformation. So in this case, it looks like again it'd be a reflection or a flip to get that from there to there. So that's some notation. You see these arrows, it's talking about some transformation that that moves those two. All right. So again, that's our image because of that mark. And then our first actual transformation is a translation, which is a slide. So it says it's an isometry, which means that it leaves with a congruent shape, and all the points and move some distance in some direction. All right, so same distance in same direction. We'll also often draw an arrow to show what that is, and we keep track of that with the x, change in x, and the change in y. So over here we have a translation of the blue square to the red square. And I go 4 units right and 2 units down. The way that looks is I start with, let's say, point A, I go 4 units right, I go 2 units down, and that becomes A prime. That's my transformation. In this case, it's a translation. And then the thing that looks a little tricky is I have a rule that shows me what to do with this ordered pair. All right, so xy becomes x plus 4, y minus 2. That's the plus 4 in the x direction, the minus 2 in the y direction. So that's really it. Our second type of transformation is called a reflection. And again, this one will probably seem familiar. So a reflection or a flip, it's an isometry, which means we have a congruent resulting image. And basically it's flipped over a line. So I have some reflection line, and just like in a mirror or something, we would take this image and we would reflect it over this line. And so I have my original image is KIM, and my resulting image is K prime, I prime, M prime. So this is my pre-image, this is my image, this is the original, this is the resulting figure. There are two rules that we can help figure out where these lines go. All right. The first one is if I am on the line, then I don't move. All right. So it is where it would be itself. So you can imagine if there's a point up here that was actually on the line and I reflected it, would just stay right there. It's not going to go anywhere. The one that's a little trickier is if I'm not on the line, then R becomes the perpendicular bisector. So what that looks like is if we connect points up above, M and M prime, that reflection line has to be the perpendicular bisector. And that's going to allow us to find points when we're missing them. Alright, so that's our piece for our reflections. And then for our rotations, okay. Rotations are a excuse me, are a third transformation, and these are a turn. Right? And there's more that we need to know for this to happen. And so I need to know the center. Okay, I need to know where it's rotating. I need to know the angle of rotation in positive degrees. And I need to know if the rotation is clockwise, which looks like that, or counterclockwise, which goes in that direction. So we'll make sure we pay attention to those pieces as we go through it. What we don't want to do is mix up our clockwise and counterclockwise directions. Now, if it's not stated, right, then they are assumed to be counterclockwise. So if we're just given a rotation of, let's say, 30 degrees and it doesn't say clockwise or counterclockwise, we assume that it goes counterclockwise. So we've got to remember that as we go through this. So we'll often talk about regular polygons and their rotations, and if we remember, a regular polygon has congruent sides and it has congruent angles, and so all the angles are the same and all the sides are the same. And so it has a center in the middle that is equidistant from the vertices. Right? Well, same distance from the corners. And so if we were to draw those lines in, there's my center equidistant from the vertices. I can see that I would be able to rotate some angle that would map A onto A prime. So that's a counterclockwise rotation, and I need to be able to figure out what does this thing need to be turned around the center to move A to A prime, and I get a transformation, I get a rotation, right? If we wanted to figure that out, I would need to take the number of sides and then do 360 divided by the number of sides, right? So in this case I have 5, and so I would take 360 over the 5 is 72 degrees. So if I take this pentagon and if I rotate it about the center 72 degrees, I'm going to get a it's going to look exactly the same, but I will get a transformation that leaves this figure mapped onto itself.